Thank you very much for joining this talk. Yeah, like already said, I will talk about resource hints, but in particular, but also in general, more about web performance and why web performance matters, what can cause websites to load slow, and then I will tell a bit about how you can use resource hints as one tool to improve the downloads of your websites. So why does web performance even matter at all? So a lot of companies did a lot of studies and all came to the same conclusion that faster websites have a direct impact on sales. So for example, Amazon did a study where they deliberately slowed down their website for 100 milliseconds for a couple of users, and they noticed a drop of 1% in sales already. And if you are at the scale of Amazon, then that is a lot of money that you are going to lose. And Google also had a study where they found out that 43% of users will abandon a website if it takes longer than 3 seconds to load. So apparently, I'm one of the other 47% because I usually have to wait much longer for websites to load. So faster websites do lead to higher conversions, but I think it's even about more than money. It's also about empathy, because while we enjoy good network conditions when we are working on websites, and even if we often complain about our mobile networks, they're still pretty good compared to what others have in other regions of the world. So I think it's also about not taking anybody's time for granted and not wasting anybody's time. And we as web developers have the capability and also, I would say, the responsibility to provide the best experience to users that we possibly can. And now I would like to go into what causes websites to load slowly. And I will use an example where I will request a website from Hamburg. No, I'm in Hamburg and the website is in New York. So and this is actually a pretty common scenario. A lot of companies don't have servers in Europe and only in the US. But first we need to talk about what actually a website is. So what is a website? A website is a small document, and it contains a lot of other small resources such as scripts and styles and images. So it's usually not one big file as you have when you download a video or a binary file like a video game. So you have one small document containing even more smaller other resources. So in order to download a website, you need to make a connection. So what does it take to make a connection? So you first have to know where to make the connection to. So you need to know the IP address of the host, where you need the DNS lookup for. Then you need to initiate a TCP handshake. This is because HTTP uses TCP as the transportation layer. And since we are all delivering secure websites in the year 2017, we also have to set up a TLS or SSL handshake. So, and the thing is, what I never think about this when I look at networks, but packages do not get teleported. They actually have to travel. And in the case of my New York example, this is roughly 6,000 kilometers from Hamburg to Germany, from Hamburg to New York, and then 6,000 kilometers back as well. So how fast can data travel? So there's this awful thing called speed of light, which is around 300,000 meters per second. But actually data in fiber cables travels more like in 200,000 meters per second. And if we go back to the Hamburg-New York example, then sending one package in and getting one package back will already take 62 milliseconds. And this was only one round trip. And I would like to go through the process more in detail and show you how many round trips it actually takes to make a connection before you can send data. So as earlier mentioned, you first have to get the host name. So I'm the browser and I want to visit the hamburg.devfest.de website. So I say, hello, DNS server, please give me the IP address of hamburg.devfest.de. And then the DNS server will happily respond and give me the IP address. So this took the earlier mentioned 62 milliseconds. Now that we have this information, we can start a TCP connection to the web server. So the browser sends a synchronization package. This is how TCP connections are opened. And then the server will make some checks and send me an acknowledgement back. And after that, the TCP connection is opened, and we are already at 124 milliseconds. But now we still need to open the secure layer, which works like this. So the client then sends a client hello, which where it specifies the TLS versions it supports, the cipher suites it supports. Then the server will pick one of those versions and send back the certificate. Then the client will check the certificate, will initiate the symmetric key exchange, and in the end, the server sends the encrypted finish message as well. And then the connection is opened, but as you can see, this has already taken 248 milliseconds, and we didn't send any data yet. We just opened the connection. And this is also under the assumption of a best case scenario where we can travel by kind of speed of light, and also do not take any computation time into account, which DNS server might need to even get the IP address, or which the encryption takes. And also we neglected one major thing, and that is mobile networks. Like mobile networks in itself, by their sheer nature, always add a fixed amount of latency overhead. There's nothing you can do about it. And for LTE, this is 70 milliseconds only, which is kind of okay. But 3G, it's already between 150 milliseconds and 400 milliseconds. And if you are on a 2G network, then you're basically lost because it's almost a second of latency added to each request. And if you now take the example I just gave and add an average 3G mobile network on top, then you end up by over 1 second of time that it takes to make a connection without even sending any data. And when I researched that, I was kind of the impression that can't be true. So that must be, I don't know, I must have miscalculated somewhere. So I ran a test. I used a web page test.org. I don't know if you ever heard of that. This is actually a pretty great service where you can test your web performance with. And I made a request from Frankfurt to a US server. I don't know which city exactly, but it's usa.gov. Under 3G network circumstances. And you can see this waterfall chart. I hope can you see it? I think it works. And this does not include the download of the page, so I covered that with my, with this awesome thing there, with the icon. And this is only the opening of the connection. As you can see, it stops at roughly 1.2 seconds. So it really takes 1.2 seconds to connect to a server in the US before we can send any data. And this is pretty significant. Well, but now we've opened the connection and we can send data at full speed right away, right? Well, no. Because in TCP, there are algorithms in place that that protect the network from congesting and collapsing. And for example, it also tries to make sure that the receiver can actually request the amount of data it advertised. And it does it by only starting slowly sending data. And this algorithm is called TCP slow start. And it works that it starts by sending a small amount of data first. This is usually 14 kilobytes. So if you manage to put your entire website in 14 kilobytes, then you will only have one round trip and a really, really good experience. But I don't think that most people will manage to do that. But if you do, then congratulations. Then the server will wait for the browser or the client to acknowledge the packages and only then increase the amount of data it will send in the next round trip. And this is repeated until the network reaches its maximum speed. And this in the web often doesn't even happen because the connection will be closed before maximum speed is reached because the files are often not that large. So if it's a 40K JPEG, then it only takes 3 round trips. And you didn't even reach your maximum speed yet. And you have to keep in mind that this takes place for every connection you open. So if your website contains 5 images, then you will be subject to slow start 5 times. So what do we learn from this? That latency and not bandwidth is the cause of slow websites, or often the cause of slow websites. So in this scenarios, it didn't matter if you have 100 Mbit connection or a gigabit or 500 kilobyte. It doesn't matter because we didn't send much data yet. And engineers over the years came up with a lot of techniques to reduce or even remove latency entirely. So for example, there's HTTP to multiplexing, which allows you to reuse TCP connections. So if you have 5 files that are downloaded from the same host, this will only do the connection once, and then download all of the files over the same connection so that you only have the slow start punishment once and not 5 times. Then there's content delivery networks. Content delivery networks basically try to move the servers closer to the position of the users so that they're literally just reducing the distance packages have to travel, which also reduces latency. And then there is caching. And caching is awesome because once you've downloaded the file once, when you encounter it for a second time, the network won't be even touched. It will just be served from your disk because the browser has already saved it there. The issue with caching, however, is that you need to at least download at once. So you only get the benefit if you have already downloaded it at once under the slow search circumstances. And this is where resource hints come into play. So resource hints are basically a way of predictive caching. Resource hints allow you, as a web developer, to point the browser to resources, such as scripts or CSS and documents, before the browser can know that it will need it, but you already know it. So you're basically pre-roaming the browser cache, and with that, improving the experience. And I would now like to go through all of them and explain what they do and how they can be used to improve performance. So the first one is Preconnect. And with Preconnect, you can tell the browser to already resolve, so like do everything I just earlier mentioned, resolve the DNS and open the TCP connection already. And this is can be used for the current navigation, for data that you need for the current navigation, but also for data that you will need soon for later navigations. And I will give you an example so that it makes all more sense. Web fonts. Who loves web fonts? Okay, well, I don't. Anyway, I built this website. I'm selling cats. And this website totally needs web fonts because otherwise it wouldn't look this awesome. The issue is I also want to have a fast website because otherwise I would lose sales, and these kitties really need a new home. So, but what can I do? Let's look at the head of my website. So I have my style sheet there. This is just the style sheet of my website, which contains all the fancy colors that I have, and also contains the font family configuration that I want to use this web font. But then there's also the Google APIs font, so Google API font. I don't know if you know it, but Google offers a service where you can download web fonts from, and this is the fonts.googleapis.com. And you have to download the style sheet from their web page. This style sheet does not contain the font file itself, but only a reference to the font file. But we will come to that soon. So this is my style sheet. It contains a matcher that matches every element because I really want this awesome font for everything on my page, and also this color fuchsia. And this is the content of the Google font sheet. I will just call it Google web font sheet because it's not the web font itself, but the style sheet that contains the information to this web font. So you have the font face definition with the font family in, where they reference that IndieFlower actually lives under this URL. So, and now let's have a look at the waterfall chart if I just open my website. You can see over here, so the first one is DNS, then it does TCP and TLS, and then this is the actual download of my website. So the first one is the HTML file. Then the browser will immediately see my style sheet and the Google style sheet because they are both in the head and they use a pre-scanner so they don't wait for everything, just download everything, it downloads everything it can see. But only after my style sheet and the Google style sheets are both downloaded and evaluated, it will download the web font itself. And this is because browsers try to download as little data as possible. And so they only download the web font if I actually want to use the web font and when the web font is available, and they only can know that when they have downloaded both and applied both and checked the selectors against my DOM. So it takes some time. So it only starts downloading here, and here it has to do, again, DNS, TCP, TLS, and the download. But we can do better than this, because we know that we are going to need this web font. In this case, we actually don't know the entire URL, because in Google Web Fonts, the path is not stable, so it changes every and so often. You cannot know why. It could be in 5 minutes, could be in 1 year, you don't know. But what is relatively stable, or it has been for years at least, is that it's going to be served from this host, from fonts.gstatic.com. And this is where we can add a Preconnect resource hint to our page. But how do we do that? It's actually pretty easy, easier than I would have expected, to be honest. So you can simply add a link tag to your head with the relation set to Preconnect and the href set to the host that we want to preconnect to. And this is, in this case, fonts.gstatic.com. I will come to this cross-origin attribute in a minute. And if we add this to our head, only this additionally, then our waterfall chart will look like this. So still my website will be downloaded, and then it will see both style sheets and download them in parallel. But this time, because we told it to, it will already do pre-resolve the DNS and do the TCP and TLS handshakes, although it hasn't seen the web font itself yet. But we told it about it. So when the browser then knows that it needs the web font, it will download the file, but it will download it right away because we already pre-resolved all the other stuff. In this case, we were able to remove over 1 second of the page load time, which I think is pretty cool in this case. Yeah. So cross-origin. Cross-origin is interesting because fonts are interesting. Fonts are subject to the same origin policy, and the font face specification requires you to download them in anonymous course mode. And for some reason, I don't know, browsers seem to maintain a different pool of connections for those anonymous course requests. I have no idea why, it just is what it is. So you have to add the cross-origin attribute, because otherwise the browser would open a second connection and you would lose all the benefit. But you can just add it and be happy. Since it's just link tags that you have to add, you can actually also use JavaScript to add them to your page, which allows you to be pretty smart about when you add them. And I would like to give an example. So this is how it looks like if you do it with JavaScript. And what you could do, for example, is that, I don't know, pretend you have a list of links on your page, like anchors, not link tags. It's a bit ambiguous, sorry. Bit of anchors on your page, and they link to xing.com, for example, or to hamburg.devfest.de. And what you can do is, as soon as the user hovers over the link, you could add this linked Preconnect to your head, and then the browser would already resolve this URL. And once the user clicks on the link, the page will load not much slower, but faster, of course. But well, you would have to be pretty altruistic to do it for other hosts. I mean, what do you care about the navigation times of other websites? You could do it. And you can specify, you can use JavaScript for all of the resource hints. Like every resource hint can be embedded with JavaScript as well. Let's have a look at the browser support. This is the can I use table, also a pretty useful service if you haven't seen it yet. And we can see that Preconnect is already supported in Firefox and Chrome, and of course Opera, because it uses the Chrome engine. And in Edge, kind of, apparently. So I think it's already justified to implement it, because I know Chrome and Firefox combined may already have 75 or 80% may cover 80% of users already. So. Next one is DNS prefetch. It is kind of similar to what Preconnect is doing, but it's only doing the DNS pre-resolve, and it doesn't open the TCP connection. And this is useful then when you know that you're going to need a resource, but you don't know when, because in Preconnect, if you open the connection, there are server implementations that may close a TCP connection if there is no data sent in a couple of seconds. So it doesn't make sense to open the connection if it will take another 15 seconds before it's going to be used. Then you can use DNS prefetch. And I would like to give a practical example. So this is Amazon. And Amazon has a pretty fast autocompletion. I don't know if you've ever tried it, but if you haven't, then try it. But the service itself doesn't run on Amazon.com. but it runs on completion.amazon.com, which is a different host. And what they do to give you a good experience, even if you type the first letter, is that they add to the head. I just copied it from the head, so it's not made up. They add a DNS prefetch link tag to their page, which pre-resolves the DNS of completion.amazon.com, so that when you start typing, it will be much faster because your client, your computer doesn't have to resolve the DNS because it's already happened. And just to make things complete, there is a third way to specify resource hints, and this is through HTTP headers. So you can also, instead of putting it into your HTML or using JavaScript, just put it in your HTTP response. And I haven't measured it, but I think it might even improve things by a couple of milliseconds because the browser is going to see your headers before it's going to see any body. So maybe it will just start downloading once it encounters those headers. But I'm not sure. It might be. Let's have a look at browser support. So browser support is really decent. So it works across the board apart from iOS Safari. And this is a thing that we will encounter pretty often, that things work everywhere except for iOS Safari. And this is actually pretty sad because on iOS, you cannot have a different browser. So if you install Chrome, you're still using Safari rendering engine. So I don't know. Anyway, if you actually want to use Preconnect, but also want to give browsers that don't support Preconnect at least something, then you could do something like this. You could add both DNS prefetch and Preconnect. And browsers that do support Preconnect will just use Preconnect and ignore the prefetch. And browsers that do not support Preconnect will ignore the Preconnect, of course, because they have no idea what it is, and will use the prefetch instead, which is pretty nice. Then we have prefetch. And with prefetch, you can download resources that you are going to need later. So they will be downloaded as in a low priority, but the browser will put them in the cache. So if you will need them later, then they will be served without any latency. And my example is, in this case, an online store. An online store has a pretty clear flow. So I will come to my cat shop, and then I will go to the cart page. And once I'm on the cart page, you can be pretty certain that I will visit the checkout as well and then make a payment. So what you can do is, once I land on your cart page, you can already download assets and files and resources that are going to be needed for the checkout. So if you, for example, have a different JavaScript bundle for your checkout, then you can already prefetch this. Or if you have images that are super important for the checkout, maybe the thank you image, I don't know. So and once I click on the go to checkout button, things will load much faster than if you hadn't done it. Another but similar example is the login page. So for example, if I start typing into your login form, you could already prefetch the resources that I'm going to need for the login experience, making the login much faster. Also pretty good. Browser support? Yeah. As we can see, it works across the board, apart from Safari and iOS Safari. Yeah, but I think, no, is it green? No, it doesn't work in Safari yet, unfortunately. But other than that, it's pretty good supported. So no need not to use it. The next one is really pretty interesting, and this is pre-render. So with pre-render, you can actually download an entire document, or tell the browser to download a document, download all of its resources, and execute our scripts, and then hiddenly, like literally, pre-render the web page and keep it hidden so that when the user decides to navigate to this page, it will be there instantly. There will be no network at all. The page will just be there. And it looks like this, so you could just edit and render pre-render DevFest, and when I click the link, it will just be there. You can even, and this is kind of weird, so this is a resource hint, and you can give a hint for the resource hint. So pre-render supports the PR attribute, which stands for probability. So you can tell the browser how likely it is that the user will actually go to this page soon. So for example, you could, when the link scrolls into the view, you could add this tag and set the PR value to 0.3 maybe, and once the user hovers over the link, you can set it to 0.9 to tell the browser that now it's going to happen, probably. But let's have a look at the browser support. It's a lot of red. So it's only only Opera and IE supporting it. But if you have a closer look, you can see that Chrome used to support it, and actually they were the ones pioneering all of this. So what happened? They removed it again. And actually, prerender is one of those things that sound really great on paper, but in reality aren't so much. So for example, it was barely used. Only 0.2% of all navigations contained a pre-render hint at all. But even worse, only 15% of pre-rendered links were actually used. So nobody really clicked on the link that were pre-rendered, which means that lots of resources were wasted, and not only bandwidth, but also CPUs, and therefore also batteries on mobile phones, which is pretty shitty. And yeah, for example, the mobile Chrome never supported pre-render. I think they just always fell back to Preconnect because pre-render is way too costly. Also, it had some caveats for web developers. So if the page was pre-rendered, then if you run your own analytics, then good luck, because you have to make sure that you don't track page views that are not actually page views, because you need to check the visibility API to know if this page is now currently in pre-render state or if the user is actually seeing it. And I'm totally sure that there are plenty of websites that now have bogus data. Also, you have race conditions. So imagine you pre-render the website, and the pre-rendered website changes your local storage or your cookies, but the host that does it well, then you end up in a state that isn't really predictable anymore. And also, browser vendors had some trouble with it. So when they implemented autoplay for videos, they had to make sure, and they even had a bug for that in Chrome, they had to make sure that the autoplay doesn't happen if the page is pre-rendered. So and this happened. So the page was pre-rendered, and then the music played, and you could never know where it comes from because you didn't click on anything. It just happened. And the same goes for requesting permissions. So if my website requested, for example, geolocation, then usually Chrome shows a pop-up, and they had to make sure that they don't do it if the page is pre-rendered. So it was, all in all, pretty messy and not worth the effort. But in the ticket where they discuss the deprecation of this feature, they are already discussing about alternatives, and the one I found the most promising, it's not spec'd, it's just in a Google document, but still I'm going to show it. Anyway, it's called a no-state prefetch, and with no-state prefetch, I consider it some sort of lightweight pre-render, so it still prefetches the entire document and downloads all resources, but it doesn't execute any of them, so you get most of the benefits of pre-render without much of the hassle, which would be nice. I mean, it's better than having nothing at all. The last one I would like to talk about is also the newest of its kind. It's called Preload. And Preload can be used for resources that you need for the current navigation. So not in the future, but you need them downloaded right now as fast as possible, and they should be downloaded with high priority. And I would like to go back to this example. So I still have this website, and I would like to revisit the first waterfall chart again for a second. So remember, website was downloaded, then both of the style sheets were downloaded, and only then the web font. And now I said that we cannot know the entire URL of the web font, but let's just pretend for now that we do know the exact URL and it doesn't change. And if you really want to use this, then you could also just post the web font files yourself and then be in control of the URL so you can know them. So just for this example, let's pretend we know the exact URL. And if we do know the exact URL, we can do this. We can add a link with the rel set to preload, set the request type to font. I will go into detail about this in a minute as well. And then set the href to the exact URL of the web font. And that tells the browser, please download this file as fast as you can. And our new resulting waterfall chart will now look like this. So after the website is downloaded, there, then my style sheet is downloaded, and also the Google style sheet is downloaded, but also the web font file is already downloaded, although the browser hasn't even discovered it yet. And this is pretty awesome. This also removes, again, seconds compared to the Preconnect variant we had earlier. And I think this opens a lot of opportunities for saving latency. Yeah, we have seen this one, the as attribute. It's for setting request types, so you can set various request types in Preload. For example, scripts, which is useful when you have an inline script loader that loads third-party scripts. You can also, of course, can preload style sheets, images, which can be used for background images that you reference in CSS that will only be discovered lately by the browser, but that you think are really important to be shown as fast as possible to the user. And what's also awesome, you can even preload fetch, so that means you can preload AJAX requests as well. I won't go into detail about that, but this is pretty awesome. But why do you need to set this at all? What gives? So the thing is that the browser will use it to prioritize the request. So style sheets will be downloaded in a higher priority than images, for example. But it also uses it to set the appropriate accept header for your servers, so that the styles will have a different accept header than images again. But it also uses this to enforce content security policy. And the content security policy allows you as a web developer to specify from which hosts you want to allow images to be downloaded, or scripts to be downloaded, or fonts to be downloaded, or anything to be downloaded. And Preload will take this content security policy into account. And if you try to preload from a host that you didn't allow, then it will just don't do it. And this also means that if you fail to set the request type or set an incorrect one, then you will neglect any of the advantages and you will fetch twice. And you totally want to avoid this. So don't set as script and then load an image. This wouldn't work. Preload can also help you with responsive design. So responsive design is basically the art of making your website work on multiple screen sizes. And this includes, for example, also serving different sizes of images. So in this example, I'm using CSS media queries to specify that if the device is maximum width of 320 pixels, then I want to download a small image. And if it's larger, then download a large image. And you can do the same with preload hints, which I think is super nice. You can just add your media attribute and put your media query in it, and then the browser will only download or only take the preload hints into account where the media query matches. So, yeah. Earlier I said there are 3 ways to embed resource hints, right? So we have the HTML version, we have the JavaScript version, and we have the HTTP header version. For preload, there's actually a 4th one, and that is it got its own status code. And this is HTTP status code 103 early hints. And this allows you to send preload hints to the server before the HTML is actually generated and before it sends its final response. And and in order to understand it, at least I wasn't aware of this, is that in HTTP, one request doesn't have to necessarily result in only one response. So the spec states that a client must be prepared to accept one or more status responses prior to a regular response. There's, for example, already status code 100 continue used for years by some people. So what you can do is when the server sends the request, you can immediately respond with the resources you're going to need. Maybe you have configured them by route. I don't know. That's up to you. And then the server can, in the background, calculate the final response, for example, by connecting to databases or calling APIs. And once it's finished, it will send the rest of the result with the status code 200 and the entire rest of the function body. I think this isn't implemented anywhere yet, but as far as I know, the spec is now finished and it's gonna happen, I'm pretty sure. Some of you now may ask, isn't this kind of what HTTP2 push is doing? So with HTTP2 push, I would just call it push now. With push, you can also send resources along with your regular response. So it's kind of similar, but it also has differences. So in push, you can only push resources that you are authoritative for. So you cannot push third-party resources such as Google style sheets or images that are not on your service. You don't have any media query support in push. And last but not least, in preload hints, you have the ability to react on load events, like on load and on error, which you don't have, and that allows for advanced loading techniques. I won't get into detail yet, but maybe we could talk about it later. I don't know. But you cannot do this with HTTP to push either. The browser support is pretty poor, to be honest, but I still like it. I wanted to use it. So it's supported in Chrome and also in Opera. I don't know, but it's also it has been in Firefox, and then it's removed, or no, they moved it into a flag. So, but you can still enable it, and I'm pretty certain that this thing will end up in other browsers pretty soon as well, because it's going to make things so much better. So we just have to wait a little more. And I would now like to close my talk with 2 book recommendations. So if you're interested in browser networking, then I can highly recommend the book High Performance Browser Networking by Ilya Grigorik. In fact, the first 10 minutes of this talk I've just taken out of this book, more or less. And it's even available for free as a PWA, as a progressive web app. Yeah, so you can just go to the website and then read it for free on your computer. And the other one is HTTP, The Definite Guide. It basically contains everything you ever or never wanted to know about HTTP, which is, by the time I read it, it didn't include HTTP2 yet. I don't know if it now does, but probably, I know, it's O'Reilly. So that's it from me. Thank you for listening, and if you have any questions, then I'll be here for lunch. And enjoy lunch.
When this HTTP2 came up, you are as a front-end developer very much into this Webpack thing, and so there was a discussion coming up when this started that you don't have to bundle anymore with HTTP2. Would you agree?
Actually, I'm not sure, to be honest, but I already know of one caveat that the one benefit of bundling is also that you get all the power of gzip or whatever compression algorithm you use. If you split it into multiple files, then you lose the possibility or you get less compression benefit. Yeah. But other than that, I don't know. I don't think that, for example, I've just read an article that HTTP push doesn't even work really well across browsers, so I wouldn't even use it yet. So I don't know. Really, I don't know.
Thank you.
Yeah, so I wanted to ask this. Obviously, you're pretty is looking to the topic of web speed and everything. And there's always been the talk of, it's important for websites to be, for web pages to load within 3 seconds. What I'm always, I don't really know is like, what actually are we measuring? What's the 3 seconds? Is that the 3 seconds user perceived, or is it 3 seconds page load time as measured by the browser? Or what is it? And how to measure it? And in the end, what do you guys measure that saying?
The answer is, unfortunately, it depends. So, for example, if you're Twitter, then you're probably measuring something like, when can I see the first tweet in its full form? This could be one metric, or when can I click on the button and actually send a tweet? So you have custom metrics. And for custom metrics, you can use browser APIs, like there's a performance observer API that you can use to set custom metrics, but also to get default metrics such as DOM interactive and stuff like this. And at Xing, I didn't measure anything yet, so I cannot really answer this. I think there are, like, server side, there are a lot of measurings going on, like server response times, time to first byte and all of that, but on the client side, at least I'm not doing much yet.
How about load measurement? We are talking about the first load, right?
Yeah.
Because it's going on most of the time. If you use technology like proxy or down, it's a little bit faster. I think
it's both.
Yeah.
But this one was actually for the first, but the subsequent ones are also as important.
One more question? Then I will give you your present. Thank you very much.